biosafety level 3 lab, and all the work starts from here. Respiratory samples are deposited for analysis. These come from the contact tracing. Then we will go to the main processing lab where the specimens from suspected cases are taken. Okay.
What is going on now? All right. Now give me this juice.
Okay. Brought in here and kept here for contact tracing. Okay. Then we go take them, step by step into the lab.
So why? Maybe I should ask why cold room?
Because we want to keep the samples in a cool condition.
Okay.
They're transported in the field in a cool condition. We want to maintain the coolness until we are ready to process the samples.
Like what temperature?
Oh, this is supposed to be like 24, 25 degrees.
Okay. But why does it look like a morgue?
Because this is so we have specimens that are kept here, and this is actually samples that we have pooled. So you can see the pools. These boxes contain samples that we have pooled. So during the process of working on them, the other box also, we will then unpool them when we have to continue the work.
Okay. So these ones are really not suspected cases, I should say?
Well, there's a mix of contact tracing and then also suspected cases.
Okay. So we have two cold rooms.
So this is for the use, and then this one is minus 20.
Any particular reason why we have difference in temperature?
This is for freezing.
Okay.
So this is for freezing. Yeah, this is for freezing. Okay. All right. It is cold. This is for freezing samples. Okay.
And how long are they kept here? Why would you want to freeze them?
So, depending on the reason, different reason for the work that we are doing. This is not just for COVID. This is for freezing, for preservation, for chemicals, and also for samples. Okay. For 4 degrees, and this is a freezer room where we have -70 freezers, and we do long-term storage of specimens here. So this is a very crucial part of the work that we do. You see that if you come to this side, you see that these freezers have specific temperature monitoring devices. Okay, when we do clinical trials, these devices can send a signal by SMS to a mobile phone to alert us when there is an alarm. So we have to ensure an alarm like the temperature has changed. What you hear is because somebody opened the freezer, so there's an alarm that will continue to sound until it reaches the set point, and then it will stop.
What's going on now? What is happening?
So Dr. Ivy Asante is in charge of...
Hello, Dr. Asante. How was your day, Dr. Asante?
Oh, it was very hectic. As usual, we had a lot of samples. So we are still receiving samples, as you can see. So this is like 200 samples, and we have already received 400 today. More than 400 actually, about 500 today. And there are some more samples here, as you can see. So the night shifts will come and then continue with those samples. So
You've been here since what time?
I've been here since 8 a.m.
And you have to close at 8.
8 p.m. So it's a 12-hour shift. So once we finish receiving the samples, we do the RNA extractions here.
What's RNA extraction?
So we isolate the genetic material of the virus so that we can detect it with our PCRs, our polymerase chain reactions. Okay.
How tedious a process is it?
So yes, so the RNA extraction is a bit involving. It takes a bit more time. We first have to open up the cells which contains the virus, and then we get a mixture of so many things, and then we bind the RNA of the virus to a silica gel, and then we perform several washing steps, after which we have to elute, like remove the RNA from the silica gel, and then it goes into a solution, and then for that we can put in the real-time PCR machines.
Okay, so for one sample, for instance, how many processes does it go through?
So for one sample, we will take you through the RNA extraction, and then we'll take you through the PCR. But we first need to receive the samples. So the RNA extraction for one sample will take, maybe for 10 samples, will take up to about 30 to 45 minutes.
Okay.
Yeah.
So prior to the COVID season, is that what you've been doing? Like, what other things have you been doing apart from now having to test for COVID-19?
So prior to the coronavirus outbreak, we work on influenza samples. So we still collect oropharyngeal and nasopharyngeal swabs and test them for influenza viruses. So it goes through a similar process of RNA extractions and then PCR.
Are you enjoying the work you're doing?
Yes, well, very much. We enjoy the work we do. Currently, it's a lot more work, but I mean, we like what we do, so yeah, it's
Family.
enjoyable coming to work every day.
Okay, but family, for instance, the reaction knowing that this is something that is killing people elsewhere, how do they react when they know that this is what you're dealing with?
After the initial shock, they are okay now, so they are fine and they are protected, so this is okay. Yeah.
Okay.
Yeah.
Thank you. We wish you all the best and good job. Thank you for the work that you're doing for us.
So as you can see, we have like many samples. And if I take you to the cold room downstairs, you will see how many samples we have. And from all the other labs, there are about 6, 7, 8 labs. We are processing samples in all of them with 2 people to each hood, processing samples. I can take you around and then you will see.
We're going to do that right
Go
now.
to the cold room, you see all the samples which are there. Come and look at the books. You see all these forms.
Okay.
Each represents one person. All these forms, each represents one person. And look at all the books. This is just a quarter or like about half of all the books that we have written people's names inside. All these books.
But do you have a system where you keep soft copies as well?
Yes,
Yeah, we
yes.
have-
We enter them.
I think it's
downstairs.
good to open the book. Can you open it so then the last number?
Oh, the last number might be somewhere here. This is 57,213. This is not even the last number. Oh. 57,404. You see. And these are not duplicates. These are one single samples, individual samples. Yes. So the 57,000, add 400 to it. Then you get 59,000.
I'm on maths lessons today at the Noguchi Memorial Institute.
400 though. 57. So the 57,000 you saw, this is the continuation, 400. And the rest are in the cold room. I can show you plenty. So this is it.
Are you able to give a rough idea in terms of the entire samples that you have together with what is in the cold room? Are you able
Oh, I think by now we should be at 99. Maybe we just did. We realized it was about 80,000, right? We have maybe 2,000 or 3,000 more. So 83 or 84,000.
Okay.
Yeah.
So we heard about the pooling system. At some
Yes.
point, I'm sure you'll take us through that process.
So before we do the RNA extraction, we pool. So like you have been told, 10 people's individual samples, we put them together as one sample. So when we test the sample and it is negative, it means all the 10 people in that pool, they are negative.
So just to illustrate what she was explaining, okay? So imagine that these are the sputum samples that you saw down there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes.
Okay? So this is sputum, we add some saline, okay? And then we take a little from each of them into this tube.
Okay.
So all the 10 samples have become one.
Okay.
So this is what we will test. If this is negative, all these 10 are negative. Then we proceed to another 10, which is like this. If this sample is positive, it means one of these or all 10 or maybe 5 are positive. So then we put this aside and then we take each one by one. And then we have to work on them. So that is what we gain by the pooling. But we don't lose anything because we are able to determine that each of these is negative. How did we do that? We took a sample which, like this, which is at the limit of the detection of our PCR. So that we know that this one is just at the limit, but we know this is positive. So we put it down and we add a little of each of these to the point at which we can detect this one. If we cannot detect this, then we cannot pool. Okay? Because if we pool it, then this becomes negative. It means we have made a mistake. So we determine the minimum quantity of the sample, which is at the positive borderline. And then that is the volume that we mix together to get our pool. which now becomes one sample that we test.
So once we have the isolate, the RNA isolate from the sample, we need to multiply the RNA so that we are able to see it, okay? So this is what we do, we start doing here. So we prepare a cocktail of chemicals. So here we have primers. These primers will then identify regions of the virus that are easily identifiable, that we are interested in. So when the primers are able to identify these regions, then we can be able to multiply. So in addition to the primers, we have things we call deoxynucleotide triphosphates, DNTPs. So then also a polymerase and enzyme. So then all these will help to multiply the region of the virus that we are interested in. In addition to the primers, the probes, the primers, the DNTPs and all, we also have probes. So these probes are linked to fluorescent dyes, you know, and they are all prepared in the mix. So this is the master mix room. So here we prepare all the chemicals and things that we need. So here no sample comes here, no RNA comes here. This is a really clean room. So we have separate set of lab coats and pipettes and everything for this room. So once this is done, we take the master mix out and then we take it to another room where we add the samples, the RNA isolates that we have now. Okay, all right.
So what we mix here is what gives you the results
It's
that
what
you
is
want?
able to multiply the region of the virus that we are interested in, yes.
Okay.
So we first prepare these ones. Then we have the probes. So I told you the probes are fluorescent dyes, okay? So once the region of the virus which we are interested in is present in the sample, as it is multiplying, the probes will begin to fluoresce. The fluorescent dye will begin to fluoresce. So once it is fluorescent, the PCR machine will pick that up and then give you a nice curve that you will see. And then yes, and then once you see this curve, you know that what you are looking for is there. Okay. So there are different targets. One is targeting the open reading frame of the virus, and then the other one is targeting the end, the nucleocapsid of the virus. You see both of them, both curves, and then there's also an internal control which checks the RNA extraction. So once you finish your test, even if it is positive and the internal control does not show, it means something went wrong with the RNA extraction. So you need to repeat that test. So all three curves should show: the open reading frame, the nucleocapsid one, and then the internal control for the RNA extraction. So when you see all three, you know that everything worked nice. So the samples that we extracted from there, we add them here. So this is also a different room, as you can see. And we work from the clean room to this place. So there's no cross-contamination of anything. Okay. You understand? So this is what she's doing. She's adding the samples now. So she's adding the samples to the master mix that is prepared in that room, the cocktail of chemicals. Okay, and then when she's done, she'll add the positive control inside here. So for every run, the negative control should be negative, the positive control should be positive, before you say that the run weight and everything is correct.
Just like a pregnancy test.
Just like a pregnancy test.
So this part is very important. That's why you see that the positive control is separate, and you have the label addition of positive control only. We want to make sure that there is no cross-contamination from the positive control to the samples that we are testing. This is very important for us. So we have a separate PCR hood for the addition of the positive control. It's a major quality control step.
With the fancy real-time PCR machines, that will pick up the fluorescence. So here we open one for you. Can you see? Yes. So here, you can take here. So here it's a clear positive sample, okay? And when you go to the report, you see everything is showing. So for the reporter 1, which is the open reading frame of the virus, this is showing. For the reporter 2, which is the nucleocapsid, is showing. And then the internal control for the RNA extraction is also showing.
So for the lame person like me, even though I did science, but I would want to find out what exactly this is. So what color does it tell you that it is positive? Which color does it tell you that it's negative?
When it is positive, you see 3 curves. Like there's 3 curves. So the fluorescence, so it just shows you 3 curves like this, and it gives you values. So these values we call the cycle threshold values. So you analyze these ones, and then you also look at the curves, and then you see that all 3 curves are there, and here the values are all present. Then the
So the
sample.
results are computerized. It's not, the results are computerized. That's what it is.
Yes, please.
Results are automatically generated.
They are automatically generated by the machine. Yes, so you put it here in the machine. There's a sample, something running, so I cannot open it. But you put it here in the machine, and then it's it's different temperature cycles. So it rises, it cools, it rises, it cools, and then it can also read the fluorescence. So once everything is done, it gives you these nice curves and also a report like this. So we don't do it; the machine does it for us. Yeah.
Okay, so after the mixing, then you put it in this, then the computer generates it.
Then the computer does it's a hot plate. Yes, with cameras that can pick up the fluorescence. So that is what it is. So it's a hot plate. It changes temperature. It rises up to 95 degrees Celsius, cools down to 50, then goes to 60, 55, 60, 55. It does all this. While it is doing that, the primers and the probes will be working. They'll be multiplying, amplifying everything. So once all that is done, the machine, when it is positive, it picks up the fluorescence. It reads the fluorescence, and then it gives you the fluorescence as a value, like the change in fluorescence over time. It gives you that as a value that you can read.
Negative, what then does the curve do? Because we've seen 3 curves. So when it's a negative case, what does it do?
I'm going to show you one. Here. So when it is a negative case, you only see the internal control. The internal control is for the RNA extraction. It checks the RNA extraction to make sure that everything went well. So here, you don't see anything. So this reporter 1 is for the virus, reporter 2 is for the virus, internal control is for the sample. So it means this is you've done like good RNA extraction, and this sample is negative.
That's a great process on this one. So you can see the process. You can see that it's not hand generated, it's computer.
And it's not like a cassette that you put it on the cassette and with 5 minutes you get results. No.
Okay.
The RNA extraction takes about 30 to 45 minutes. Preparing the master mix will take another 30 minutes, and then when you put it in the machine, it will take up to 2 hours. Okay. Yeah. And the machine, we can load 92 samples at a time. So imagine if we have pooled 92 samples. This is 920 samples, and then you can run them at the same time. So already you are running 920, and all 4 machines are working.
We've been asked what is our capacity, how many tests can we do a day? So it is variable. We can do as low as 1,000, which is not a fixed 1,000, it's just an average figure. And as you just heard, when she did the calculation, Ivy, what was the amount that you got? So 7,360, okay? So that's the amount that she's done in her shift, okay? So when we say 1,000 or we say 3,000, that is the capacity of the machine. So depending on the rate at which they work, that tells you the number of individual samples that they have done in a day. So in her shift today, she's done, that number. That is the number that she has completed. So when people ask us, how many samples can you test in a day? It's very difficult to give them a precise figure. Then this is because we are not a factory, a factory line where it's automated. This is a group of human beings trying to work together from sample delivery, sample receipt, sample processing, and then the final, result out of the PCR machine. But that's not the end of the process. Now these data, because they are case investigation forms, have to now be entered into the database that we've created, and then the results transmitted to the Ghana Health Service. Okay.
So from here, once we've had the positive case, and now that we know positive or negative, now that we know the results, what then happens? What's the next step? We go into it. Okay, so at this point, we now know a positive case, what it looks like. It's the 3 curves. When it's a negative case, you have just 1, and it's green. So then we know what it looks like, and then the capacity here in this room. So we go on to the next step. What happens when we get the case results? Follow me.
So here are the forms. Now you can see what we are talking about. The earlier batch of case investigation forms were transported to the Ghana Health Service Disease Surveillance Department.
Okay, so you don't just send the results to them, you back up with the forms and data that comes with the test.
Exactly. We send them the electronic, results, and then we send them the hard copy of the forms as well. Now, what we are also doing alongside this is that, so what we're doing is that at the same time as we're doing the data of the hard copy forms, we have a team that is using a data capture software, and they are entering the data into an electronic database so that we will have the electronic database for all the paper forms that have come for COVID. So this is another exercise that is ongoing.
So we have the task of entering the over 68,000.
Exactly.
Into
The 68,000 case investigation forms, everything on the form, from the district, the person's name, travel history, everything, symptoms, if no symptoms, and then of course the final thing is the test result. Okay. If we had had this from the beginning, we'd have had a much seamless process. But we've learned our lesson, so now we're moving to barcoding.
From the beginning?
Because it took some time, and now they're trying to catch up with the large number of forms, and then we will have a complete electronic database.
But do we know how many they've been able to enter so far?
The managers, how many have you entered so far? Almost 40,000.
40,000.
So they're halfway.
Your names and what you do?
Kujo Mensa Sergio, the data manager on capturing the red cap. Data manager for data manager. Yeah.
Okay. Well, your job is well cut out for you. Please take us through what exactly you do and how tedious the process has been.
Okay, so you can see the data entry clerks at the background. So normally when the case report form comes, they try to capture everything that is there, including the clinical course, patient signs, occupation, exposure, etc., etc. Yeah.
So how tedious is the process? I'm sure it's been tough. We used to do it, hard copy. Now you've had to enter the data for us to have a soft copy. How tedious has it been?
As far as if the handwriting is clear, then the work becomes much easier. But from the field, the handwritings are not clear, so they are not eligible. So the enumerators have to strain before keying it, and they make sure they try to get it clear so that before they enter whatever is written on the form.
We know that medical people don't really write well. That's what we've been told. But how do you ensure that the right data is inputted, even though it's not eligible?
They normally verify what they ask their colleagues to confirm what has been written on the form before they try to capture it into the system.
Okay. Well, Sergio, we'll leave it here. Thank you so much. Hello. Good evening. So we just want to understand what exactly goes on here. I see the inscription on your door. It means that all the action is right here in this room. Tell me what goes on here.
Okay, my name is Eric Behinen, a member of the data management team. So what we normally actually do is when we get the forms from the lab, which have been assigned a lab ID, they bring it here, we enter the biodata, and also when the results are ready, they also give us the result from the PCR room, which we also enter here. So in summary, that's what we normally do.
Hello.
Hello, my name is Mrs. Miriam Michen. Okay, so I send results to the various facilities who brought their samples here. So as and when the results are ready, we just collate them and then we send them via email, depending on the number of samples they brought, or by text.
You don't do phone calls or anything, right?
We do phone calls. So they call us. Some people are probably in a hurry to get their results, so they do call us for their results. And as and when they call and it's ready, we send them to them. We also call them that probably your results are ready. Probably there are so many, we can send them through text. So if you can send us your email, then we'll send them to the email.
Were you asking you what is the result? Please, can you tell us? Do you do that?
Oh, sometimes they do, but we just tell them once they are ready, we send them to them. They'll get to know what the results are.
Well,
Okay, so what you see the various institutions. If it's a hospital, you see them. So we have the total sample processed, which in summary, that is what we have received. Then you see the total sample tested, what we have tested at the lab so far. Then you see the total number of positives. So
I see 73,000.
that's what we have received.
That's what you've received so far.
Then what we tested after that time, 19th
19th of April.
April 2020.
We are honored to be given the opportunity to work on such a huge projects like this by our boss. So definitely sometimes when you see on TV and it's our numbers we are generating here, which is of course a correct number, and then everything we are doing here is genuine. We know we are putting in a good work.
Okay. So we are privileged to see the results as at 19th of April 2020. You want to give me a sneak peek into what today's results look like? And you heard Prof in the background with a big no. I can't because of the numbers you have tested.
The reason why I said no is that they have to cross-check.
Okay.
And then I have to be sure that it is the true update before it's transmitted to the Ghana Health Service. And what you are seeing there is just the total aggregate, but then what we send is the actual patient names. So when they show me the summary, I have to cross-check with the individual patient forms and then be sure that it's a true aggregate. That's why we can't show it to you, because it has the names of the patients.
So the next time you're sitting behind your computer waiting for the next update, know that these are the people that are behind the figures. So I'm sure that once they get the data quickly, we will also get the results. So be patient about it. They are trying to do a diligent work, then we can all get the best results. So we're back to where it all started at the Noguchi Memorial Institute. It's been 2 hours of a tour of this access, of this facility, unfettered access we got, and our tour guide, Professor Ampofo, joins us again. Then we can quickly wrap this up. I wish I could do it every time. Every time they get samples, you can come back and do it. I have had my time here. They didn't get it, but I'm going to tell them the story. But what do you think they should be taking away in terms of this tour that we've had at Noguchi?
So, as I said on the briefing, you cannot see the virus. For us, it's the respiratory sample, the sputum as you've seen the progress that it makes from the entrance here when it is received. It goes along with its form. Through the various labs, it goes through the PCR process so we can detect it, and then you see how it ends up in the data management room, and then the results are transmitted to the Ghana Health Service. So we ask for your patience, we ask for your understanding, we ask for your appreciation, because it's a lot of hard work, working day and night, to help us have better health. And I think we are grateful that we are in the position to be able to do this because of our facilities and our expertise. And we hope that you will understand, and do what you have to do in terms of the prescription for reduced infection with this virus.
And we thank you so much once again. And we thank you so much for all the work that you're doing. And we pray that we'll do more for God and country. And hopefully COVID-19 will be over soon. Then we can come back for other CSM, polio, and the others. Thank you so much, Professor Ampofo. And from the Noguchi Memorial Institute, I am MFR Pau, and thanks so much for your company.